Hello and welcome everyone. I'm back after a while. I'll be starting off by solving this problem called palindromic subsequences. This problem, you require to take an input as n, a value, and what you're going to have to output is an array of numbers of those n elements. Now, each and every element will be containing in between 1 till n. Okay, uh, but you see, the array that you're going to output and give the system as an answer would have to satisfy a condition. What is that condition? The condition is that the number of, remember, the frequency or the number of longest palindromic subsequence of that array should be, let's call it, C, frequency of CFR of C, should be greater than the length of the array. So, for example, let's take this one, this array here. In this array, what do you think is the maximum palindromic subsequence length? I would say there's only one of them. 1, 2, 2, and 1. 1, 2, 2, and 1. Now, do you see any other similar palindromic subsequence of length 4? Or any palindromic subsequence of the highest length, which is 4? I don't see. So let's verify for this array. The frequency of those, palindromic subsequence of the highest length is 1. Well, what is the total element of the array? 1, 2, 3, 4, 5, 6. 6. This 1 is not greater than 6. It's actually not satisfying the condition that we were trying to make. What about so I hope you do understand the solution. You have to output an array which would satisfy that condition. The number of palindromic subsequences, highest or maximum palindromic subsequence, which means the palindromic subsequence length should be the highest among all of the arrays, and how many can you find out should be greater than the whole element of the array. Now, what is the best way to solve this problem? I would say you think about it. What I thought first was, okay, if I could, minimize the subsequence, the maximum subsequence palindromic, maximum subsequence length, if I could minimize it, then I might get more number of those palindromic subsequence. So more number of those means in my favor, the solution would be in my favor. So I would be pushing myself to generate an array that would have more number of palindromic subsequences of maximum length. That maximum length should be as less as possible. What is the minimum palindromic subsequence I can get? A value of 1 length, right? For example, in this array, first I took this solution, 1, 2, 3, 4, 5, 6. Okay, this could be one of the possible answers, right? We have, if you take a look at it, what is the maximum palindromic subsequence length? It's the length. It's only a single element can be a subsequence. So I cannot see any other maximum. What is the maximum length possibly? In here, it's 1. The maximum length palindromic subsequence, which is 1. So it is in and of itself, it's 1. It's a palindrome. Now 1, 2, 3. They're all individually one length array, one length value. They're all individually palindrome. So which is also the maximum one. So I thought maybe this is the answer, but it's not. Why it's not? Because if you count the frequency of the palindrome, you would get a number called, for this array, you get 6. But what is the length of the array? It is also 6. Now the question is, does the 6 greater than 6? No, it's not. It's still not satisfying condition. I'm still in the losing position due to not getting one extra of those samples out. Then I looked at the first example that they give, the first correct answer that they give for n equal to 6, and I tried to analyze the patterns up here. What was the pattern? I tried to analyze the pattern and I realized that they already actually gave a hint by providing the first example. For n equal to 6, the answer that they gave was this, and after analyzing it, I got the pattern. How are we going to do this? So my goal would be to get that frequency greater than the length of the array. So I would definitely have to take some values duplicate. And that's the first observation that I took. And then what I did is I simply copied the pattern from this n equal to 6. Now, how did I do that? Now, for example, for n equal to 7, let's say, okay, let's take, for n equal to 7, what I did, I generated by analyzing the pattern. What is the pattern? Pattern is, I said, okay, the first value would always be 1, and then I will take value for 7, 1, 2, 3, 4, 5, okay, 1, 2, 3, 4. And then what I would do, simply take 1 and 2. This is 1 actually. Yeah. 1, 2, 3, 4, 5, 6, 7. Now, this was my solution, and I was trying to analyze whether that's going to work or not. And it did work. So the pattern is that first value would be 1, and after that you will take incrementally values of 1 from 1 till n minus 3, okay, inclusive. And then you take 1 and 2. So if I redo the solution, the pattern would look something like that, where sorry 1, and then from 1 till n minus 3, and then 1, and then 2. So that's the solution. Now the big question, why am I claiming that this is the answer? I can get the pattern, I can get a solution out here, but I need to understand the intuition behind it. How am I being so sure about it that this will provide me the correct answer? Let's try to jump right in. Let's try to analyze why it should always give the best answer. Now, first of all, you see that 1 in here, and this 1 in here. I have another 1 here. Now, as I have 1 at the first type, at the first position, and another 1 at the very, very last position. Okay, I've got 2 1s, 1 at the very first and 1 at the very last. Now you might say, have a question, why this 1 is not at the very last? Why am I putting it in here? There's also, I have an answer. I do have an answer for that question, because you see, if you provide this 1 at the very last, what it would do is you might create a palindromic subsequence of a length of maximum, but that would be a far greater And to give an example, I would say, let's say you see you have 1, 2, 3, 4, and then 5, and then let's say 1. Okay, so here's the example that I was, trying to give the answer of why you might think that, oh, hey, this one is not. It should. If I take this one here, what's the problem? The problem is here. If I take, let's take an example like that. Okay, we have this array. Now, if you analyze what's the maximum palindromic subsequence length, you'll see that it's 1, 2, 2, and 1. Now, we would always look for palindromic maximum length of 3, in the according to the pattern that I analyzed for the first example, which gave me the correct answer, 3. But you see, you are already incrementing the maximum palindromic subsequence length of 4, which is greater than 3, not fulfilling the pattern. And if it's 4, as I said before, the less the less the maximum number of palindromic subsequence length is, the better you get the final version of the solution, the more you get the correct answer. But it's not, it's giving me 4, but that's why I switched, you have to switch this thing, from earlier it was 2, 1. You cannot do this. You can't do. What you can do is what's the, what's the, what's the benefit of doing that? The benefit is that you get this extra 1, which is helping you out and giving you 1 extra palindrome of length 1, 1, and 1, and then you have 1, 2, and then you have 1, 3. Okay, so you see that solution that it just I just what would happen for this final, you see pattern for this one. I'm getting this amount of subsequence. For this one, I'm getting this amount of subsequence. And shouldn't this be greater than, it's 2n minus 5, shouldn't this be greater than n? It has to be. I mean, come on, n is like what, starting from 6, so if I even take the minimum value of n, 6 times 2 becomes 12 minus 5, which means what, 7. So 7 is always greater than 6. So that's the final proof of this pattern right there. This is the proof. You get 2n minus 5, which should always be greater than n, as it's being proven for the minimum value of n, which is 6. For 6, I'm saying that 2n minus 5 giving me 7, which is greater than itself, the length of the array, which is n. So I hope you do understand. I did understand the solutions of this problem. The code is just absolutely, easy peasy. You just do this. That's it. Simple solution, and this is how you solve it. So, yeah, thank you very much.